Reinhard, Genzel and Andrea, Ghez, an alternative interpretation within a unification framework. Abstract. Observations conducted by Reinhard, Genzel and Andrea, Ghez have established the presence of a compact object at the center of the galaxy. Within the present unification framework, an alternative interpretation is proposed in which this object is not a black hole but a dense configuration of multiple stars forming a coherent gravitational and electromagnetic system. This work outlines the conceptual basis of this interpretation and discusses observational considerations that may support further investigation. 1. Introduction. The identification of a compact mass at the galactic center has been widely interpreted as evidence for a supermassive black hole. This interpretation is primarily grounded in the predictions of general relativity and supported by high-precision stellar orbital measurements. However, alternative models may be considered within broader unification approaches that seek structural and dynamical analogies across different cosmic scales. 2. Theoretical framework. Within the proposed unification model, stellar systems can organize into complex multibody configurations analogous to molecular structures. In this view, multiple stars may form tightly bound systems, here referred to as stellar molecules, in which gravitational and magnetic interactions contribute to their spatial organization and dynamical stability. Such arrangements are already observed in binary and higher-order stellar systems. In galactic nuclei, where matter density and environmental pressure are significantly higher, these interactions may lead to the formation of large-scale aggregates or macrostellar configurations. These structures could, in principle, account for the observed compactness and dynamical behavior typically attributed to a central massive object. 3. Observational considerations. A relevant observational aspect concerns the visibility of stars in the vicinity of the galactic center. Under certain simplified assumptions, the presence of a classical black hole might be expected to produce observable effects such as transient obscuration or loss of visibility when stars pass behind it, due to light absorption. However, the apparent continuity in stellar visibility, as inferred from observational data, may be interpreted as consistent with alternative structural configurations. This point does not constitute conclusive evidence but suggests a possible line of inquiry that may complement existing interpretations. 4. Discussion. The dominance of quantum relativistic frameworks in contemporary astrophysics provides a robust and widely accepted basis for interpreting high-energy and gravitational phenomena. Nonetheless, the exploration of alternative conceptual models may offer additional perspectives, particularly in contexts where observational data allow for multiple interpretations. It is important to emphasize that the alternative interpretation presented here is intended as a conceptual extension rather than a refutation of established models. Further theoretical development and empirical analysis would be required to assess its viability. 5. Conclusion. The compact object at the galactic center, as identified by Genzel and Ghez, remains a subject of significant scientific interest. While the black hole model remains the prevailing interpretation, alternative frameworks, such as the multi-star, stellar molecule model proposed here, may provide complementary insights. Continued observational and theoretical work will be essential to refine our understanding of these extreme astrophysical environments. Supplementary note. A referenced video is provided as a visual resource in which the continuity of stellar visibility in the galactic center region can be examined in detail. https://www.youtube.com/shorts/5p9ib4-UIC